Hello all. Today we are starting our new phase, phase two, AUTOSAR in depth. So in the AUTOSAR, whatever we are learning, that will be documented as a video, and also this PPT will be shared to you. And just be with me throughout this journey, and we can make it enjoyable. Okay. So starting with the AUTOSAR, what is the AUTOSAR basically? So the full form, this is the basically AUTOSAR is the abbreviation, and that abbreviation is of Automotive Open Source Architecture. Okay. So this AUTOSAR is made up of Automotive Open Source Architecture. So what is the meaning of this particular line is it is the AUTOSAR architecture, no doubt for that, because we are using this particular architecture for the automotive use. Okay, so when we say automotive use, it consists of code uh, creation for, let's say, tractors, or let's say car, bus, vehicle, any vehicle, whatever we see. If they want to establish a proper uh, code with a proper stack, they can use the AUTOSAR as an architecture. And along with the architecture, if they set all of their code in that sense, they can easily make their code flexible, independent of the hardware. So going forward, we will be seeing what is the different advantage of AUTOSAR, why AUTOSAR is more widely used in the market, and why not the conventional embedded software which we are already been using, or a conventional OS and all those things. But the AUTOSAR is a different thing which is being developed since few years, and it has been very popular and useful in the automotive domain. So and the open source means basically this is the open source. So no one has patented it, and it is open for all the what we can say OEMs and the suppliers who use it. Means this technology, whatever the documentation of the AUTOSAR is there, that is freely available for all to use. Okay. Now, going forward, and go, what is AUTOSAR? Okay, so we already know the full form of AUTOSAR, that is Automotive Open Source Architecture. But what is this AUTOSAR is? Okay, so AUTOSAR, let me take a pen. So the AUTOSAR stands for Automotive Open Source Architecture, then open system architecture, then it standardizes software architecture for automotive ECUs. It is open source, and its specification and the documentation are available to all. That is what I have told you, that whatever the documentations are there, it basically given to this particular website, autosar.org. Whatever the documentation are there, there are huge documentation for the AUTOSAR. All of them are available on this particular website, and it is free to all. Okay, so no need to pay any money or anything. Okay, if you want, you can also download it. That's why it is open source and available for all. Then it is growing and evolving standard that defines a layered architecture for the software. Yes, AUTOSAR is a layered architecture that in going forward lectures we will be getting the information how and in what way it is layered architecture. That is a good thing, and it is growing and evolving. Why? Because so many companies has tie up with AUTOSAR. They have introduced themselves in the AUTOSAR, and and by that way they have evolved in so many parameters. Okay. So when we use AUTOSAR, there are so many modules coming in picture, and module by module you can divide it to the different teams. You can divide it in the different companies, and specific to that model the different teams or the companies will be working, and in that sense a particular code which will be generated at the end will have more improvement, more flexibility, and more accuracy depends. So that is the advantage of AUTOSAR. Then the classic AUTOSAR platform runs on the microcontroller, and it's divided into three main layers. So when we say it is a layer architecture, it has three layers. That is, one is BSW layer, another is RTE layer, and another is application layer. So what these different layers are, we will going forward, we will just go through it, and what are these particular layers and whatever we can find out. Okay. Now there is a term classic AUTOSAR. Okay. Now this classic AUTOSAR means when first time AUTOSAR has been introduced, it has been named as the AUTOSAR, but nowadays there is another variant of AUTOSAR has been developed inside market, that is adaptive AUTOSAR. So what is the difference between classic and adaptive AUTOSAR? Okay, so whenever we say classic, it has already has the layered architecture. Okay, but in adaptive AUTOSAR, some of the layers has been merged according to the application. So that is the difference. But in this course, we are focusing upon the classic AUTOSAR. If you have very strong knowledge of classic AUTOSAR, it is very easy for you to get in touch and getting the knowledge of adaptive AUTOSAR. Okay, so this is what the AUTOSAR basics is there. Okay, so it is nothing but a architecture by which your code and your all the tool chains has been or will be structured. Okay, by which the code will be in a proper structure and it is independent of hardware. Okay, so when we say independent of hardware and it's a structure kind of thing, that what is that we will be going to learn. Then uh, what is AUTOSAR in real life fact? Okay, so what is AUTOSAR? We already understood. Okay, in technical way we have understood it, and in general way also we have introduced it. But in real life fact, it means it's as per my experience and my knowledge of AUTOSAR. These are the real life facts which I want to share with you, and that is what is important inside the current market of AUTOSAR. Okay, so when we say AUTOSAR, it's not a simple topic. Okay, it is a very vast topic, and around 25,000 plus different documentation are there. If you go on this particular website, okay, if you check what are the documentation, you can see 25,000 plus documentation for the AUTOSAR. Okay, so seeing that particular number, we cannot imagine the depth of the AUTOSAR. That is the first thing. Second thing, one person alone cannot learn whole AUTOSAR. That is the real fact. That's why this slide is for real facts. Okay. Now, if we say that, okay, so what would be the solution for that? Okay. So solution is one can only study and the master of a specific stack in the AUTOSAR. Okay. So I already told you there are some layers in the AUTOSAR. Okay. Let's say these are three layers: BSW, RTE, and there is a application layer. Okay. Below it there is hardware, also called as MCAP. Yeah, we can study this afterward. But let's say these are the three layers. Okay, this is the layered architecture of AUTOSAR, but there are some vertical division of this particular stacks also. Okay, so these particular layers are vertically also divided. Okay, when we divide it vertically, this particular vertical section, this is the vertical section, but is the combination of the application RT, BSW, and MCAP. This particular vertical section is called as a stack. Okay, so one person can ideally learn one stack or two stack maximum. Okay, and he should learn that only, because if he wanted to learn all the AUTOSAR, it is not possible because so many documentation are there. So what we need to target any one stack. Okay, and we need to study that stack from lower layer to higher application layer. Okay, if we are master for that particular stack, then it is very good for us for applying in the job market and get a good position in the AUTOSAR. Okay. Now, diagnostic stack and com stack are more commonly used stack because it has so many changes throughout the life cycle of the project, so has more potential to get placed in a company. Now, uh, from these different stack, there are two stack called as diagnostic stack and com stack. Okay, com stack means communication stack. Diagnostic stack is a diagnostic stack which used to diagnose different failures inside the vehicle. Okay, and the communication stack used for the communication between so many components, so many ECUs of the vehicle. Okay, so these two stacks have basically have more variation, okay, more changes coming inside the whole life cycle. Life cycle meaning from starting of the project to the ending of the project, there are so many changes occurring inside this diagnostics and form stack. That's why we will try to learn about this diagnostic stack more. Or com stack is, if you see, there is only 20% change in the com stack and diagnostic stack. We are focusing on the diagnostic stack in this particular course. So why? Because diagnostic stack has a more potential to get placed in a company. That's why, and why it is so, because a diagnostic stack has very different changes coming in the picture in the whole life cycle of the project. So uh, diagnostic stack has more requirement, diagnostic stack has more changes, diagnostic stack require more people, and that's why the placement opportunities are more. That's why we are going for the diagnostic stack uh, understanding in this particular class. Now, before getting the knowledge of AUTOSAR diagnostic stack, we must go through UDS protocol to understand all things clearly. Okay, so for this particular AUTOSAR phase to be understood, we must have the UDS protocol knowledge. Okay, and that's what is there inside phase one of this particular course. So if you have not completed that, please complete them and then come back to this particular lecture and start with the phase two. Okay, so phase one is what very necessary to be comfortable inside this particular AUTOSAR placement. Okay. Now, AUTOSAR is only a architecture for documentation and follow. Ultimately, the code will be generated in the .c.h file structure in a project, and you will really cannot identify which file represent which layer. Yeah. So this is very important point. Okay. Why? Because each and everyone will tell, yeah, I know AUTOSAR. AUTOSAR is this, that layer architecture, BSWRT application. So many things can be there, but when you see the code, okay, ultimately this is the architecture, okay, not the code or style of writing the code. Okay, it is the only architecture by which different modules of or different functions can be divided into different layers. Okay, so ultimately by using the AUTOSAR architecture, ultimately the code will be generated in the .c and .h file. Okay, and by seeing that .h and .c file, there is a huge number of .c and .h file will be generated inside this particular AUTOSAR project, any one AUTOSAR project. And you, when you see and go and check that particular .c and .h file, it is not possible to identify the particular .c and .h file is coming in which particular layer or which particular layer or a section of the layer. Let's say you cannot identify. Okay, yeah, some of the files are predefined, that is identifiable. Means if this particular file is going to the BSW or RT or the application, but remaining what are the standard remaining from that, you cannot identify which file is for which particular layer. Okay, that's where the engineering term comes. Okay, so we are learning this particular AUTOSAR for that particular use only. Okay, by seeing .c .h file and by seeing the calls and all those things, how we can identify for which application for which particular layer this particular code has been made, this particular .c or this particular function has been made. So that is our work. Okay, so going forward we will try to understand that thing also. Okay, so if we are means eligible for understanding at least 30 to 40% of .c and .h file where it belongs in the BSW or RT or application, we are in the good shape. Okay, that is our target. Then this was the background of the AUTOSAR, real time facts and all those things. Now, what is the need of AUTOSAR? Okay, so this is the very important thing. Why? Because before AUTOSAR, there was the implementation. Okay, there was all the things in place. Vehicles are running on the software also before that. But why we needed this AUTOSAR? Okay, and what it has made the changes so that every company is running behind the AUTOSAR and implementing all their softwares using the AUTOSAR architecture. Okay. So uh, when the complexity increases, we need to have the simple solution. That is the very simple mantras in any domain, not in the automotive, any domain. Okay. So in the automotive domain, what happened now? By the increasing demand of the automotive or the vehicles we can say or the buses we can say, there is a complexity introduced. Means in the starting only steering, those are in the in the manual or mechanical thing. Okay, but going forward, that steering has been automized. It has a ECU coming in picture, which is basically taking control of that particular steering. Automatic power steering has been introduced. If you release that, when you go for the U-turn, and when you release that particular steering wheel, it automatically come down to its original position. So for this particular thing, ECU will be required. ECU means electronic control unit. Okay, so that is nothing but a microcontroller, higher level microcontroller, that has been introduced for the engine manipulation and engine health monitoring. A particular issue require transmission, then seat belt detection, then windows up down and all those things. So as the vehicle has been introduced and updated, there is an increase in the complexity. Okay, then modern vehicle, especially their EE systems, electrical and electronic system, was mainly motivated behind the development of the auto. Okay, so the motivation comes from the EE system, whatever I have told you. No? So for each mechanical things previously available for uh, the vehicle development, those are being added with the EE systems, electrical and electronic system, along with the mechanical system. So that was the motivation of the AUTOSAR. So whatever the electronics and EE system has been added inside the vehicle, basically those are running on a particular embedded C software. Okay, so that software day by day has been increased with the complexity. Okay, and that complexity is means, let's say whenever that particular complexity has been introduced, it is very difficult for maintaining that particular code. Okay, and whenever a particular bugs comes in that particular code, it is unrecognizable which module to debug. Okay, where that particular scenario to be handled. Okay, one thing. Second thing, if a particular hardware has been changed throughout all the code, whatever the tens of thousands or lakhs of lines code you have written, all the code should be rewritten with respect to hardware. That was the very critical thing for the AUTOSAR. Now, today's vehicle have more than 100 of ECUs. Okay, whatever I have told you, for each application you need ECU, and today's vehicle have 100 of ECU. Every one of them has thousands of functions. Okay, that is the very simple, because we know functions are used for doing any particular function, and we have very integrated circuits ECUs to handle different things. Okay, and has the thousand lines of code or functions we can say, then without this standard, they often have been completely rewritten when the hardware is changed. So this is very important. Why, I will tell you. Now, this is what the diagram you need to check. Let me erase this. Sorry. Okay. This is the conventional software what we written. You may have written in your colleges also, that let's say you have a PIC microcontroller. Okay. So PIC microcontroller, it has its main assembly language or low level coding. Okay. Whatever you are writing, it is written on the basis of PIC microcontroller. Means memory location. It has its own memory location. It has its own I/O. Okay, let's say tomorrow I just replace this PIC microcontroller with STM32 microcontroller. Okay. When we say STM32 microcontroller, it will have different memory addresses. It will have different IO controls for pin position. So by this, the whole code, whatever I have written for the thousands line, had been replaced again rewritten for the STM32. Okay, this is what the simple embedded softwares are doing. Okay, prior to the AUTOSAR. Now, this is okay if you have one ECU. Okay, you have means converted or replace it with the other ECU, another microcontroller. You are writing the 1,000 line of code again. Okay, no matter. But when you have one more than 100 of ECU and their hardware has been changed, how you are going to change all those things or rewrite all the codes? Okay, by this situation, the big companies will be going for the bankrupt, and they cannot do their projects on time. Okay, that's why the AUTOSAR has been introduced. Okay, where you can see this particular layered architecture, hardware and software, only two layers are there. And this hardware, you can see it has been embed inside the software also. It is not differentiable. Okay, this is not having a single line. It is somewhere the hardware is introduced in the software, and software also introduced depending upon the hardware. So this is making very complex code. Okay, now on the right side, whenever the AUTOSAR has been introduced, okay, what they have created, they have just separated different layers. Software layer has been differently introduced, and hardware layer has been differently introduced, and in between that, the AUTOSAR framework has been fit. Okay, so let's say whenever the hardware been replaced, let's say you have using PIC microcontroller, now you have changing it to the STM32, your software implementation code will not be changing. Okay, meaning inside this particular PIC microcontroller, if you have used the LED on and LED off code, okay, now that LED on and LED off code will have a particular simple function. Okay, that function comes under the software. Okay, that will not be changed anyway. Okay, only the supporting functions or supporting things of those LED on off will be changed. That is what this AUTOSAR takes care. Okay, and how it takes care, we can go and check in the next videos. But as of now, I can tell you that those changing and all the things takes care by the AUTOSAR. So whenever any hardware changes, no effects on the software, whatever application software, basically whatever you are writing. So that's why here hardware specific things, the lower layer of the AUTOSAR takes care, and the top layer standardized interface are there, and that is been taken care by the AUTOSAR. Okay, and then this has made it urgent for the automotive manufacturing giant to come together and make a software independent from the hardware. To make that possible, they set AUTOSAR as an industry-wide standard, which was a core solution for the software to become reusable. Okay, so that's why this is the very complex thing happening, and so many companies are struggling. So whatever the automotive manufacturing giants do, so big companies came together and thought about it, and how can we have the solution for that, and they have implemented AUTOSAR. Okay, and it has been industry wide standard, and it has made open source, and by that we are using our software reusable. Okay, so whatever we are just replacing the code over here, we are not replacing the code of 1,000 lines. Only 20-30 lines will be changed, and remaining code will be same, and that's what we say software reuse. Now, yeah, this we can take afterwards. So these are the AUTOSAR partners. So these are the companies which came together and implemented the AUTOSAR. So these are very big thing, very big companies who have joined hands and implemented AUTOSAR inside their software, and they are uh, implementing it since 2003, and by that they have earned so many money and reusable code, and they have delivered their projects very early. Okay, so from this, Bosch is in India, Continental is in India, Daimler is in India, then GM is also in India, Siemens is also in India, and yeah, the remaining companies, whatever you can see, their tier three suppliers and tier two suppliers are working from the India. Okay. Now, AUTOSAR use cases are, there are four different use cases of AUTOSAR. That is the first one, OEM. What is OEM? OEM is original equipment manufacturer. So these are the OEMs, okay, which who are implementing original components inside the vehicle. Okay, OEM overlapping reuse of software modules. They are reusing by the AUTOSAR introduction. They are using their software. Then highlighted design flexibility. They can design a different things. Then simplification of integration task. Okay, so when you have different modules inside a particular layer, particular stack, you can integrate it easily. Then reduction of the total software development cost. Okay, that's what we have already discussed. If they are reusing their existing code, they will need very less time to modify a particular application or the software for the next delivery. Okay, and that is the best advantage that has been get to the OEM. Okay, now supplier are the parties or the companies who supports OEM to develop some of the features. Okay, let's say they are implementing a diagnostic stack and they are providing to the OEM. So OEM is the boss, what we can say, who is the car manufacturer, like BMW, then Volkswagen, Toyota, GM. These are the OEM. Okay, supplier mean whoever supports them to do different things that OEM solely cannot do it. Okay, so OEM cannot implement all the parts of the whole AUTOSAR. There are so many stacks coming in between, so they can take some of the stack from the supplier. Okay, so supplier development partitioning among suppliers. Okay, so different stack been taken by the different supplier and they are delivering it. Increase of efficiency in functional development. So whatever they are implementing in the functionalities, okay, their efficiency has been increased because it has been divided into different stacks and modules. Okay, then new business models possible. So by this division of different layers and stacks, okay, so new business model has been established for the suppliers. Now tool providers. So now the main thing is AUTOSAR, as I have told you, is a architecture. Okay, so architecture and one more point we have gone through that ultimately the code has been generated into .c and .h file. Okay, so if AUTOSAR is having different architecture and the code is we cannot identify the code, so there should be something who is really generating that particular sequence. Okay, so their tool provider comes in picture. So tool has their configuration software or the tool we can say, and they have stack wise distribution, layer wise distribution inside their tools, and we basically configuring it, and after that the .c and .h file will be generated. Okay, so common interfaces with the development process that has been introduced by the tool provider, and tool provider giving their tool to OEM also and the suppliers also to generate a proper code of AUTOSAR. Then seamless manageable task optimize, time dependent and tool landscape. Okay, so tool has been implemented to give accuracy, and that's why the tool provider are image. So the main giant is a vector. Okay, vector, then itas are the tool provider. Okay, and OEM, as I already told you, the big companies like Maruti Suzuki, Honda, these are OEMs, and the suppliers are the companies who are providing them some of the services like Bosch, then we can say ZF. Okay, then KPIT, we know. These are the suppliers. Okay. Now, new market entrant, whoever the company wanted to have their new vehicle, means they are newly becoming OEM. Okay. So transparent and defined interface enable new business model and get the technology habiting. Okay. So by use of the AUTOSAR, the new OEM introducing first time in the market, they are also been taken this as a positively. They are using using uh, AUTOSAR architecture for implementation of their different modules, and from that they are coming in the cutting edge technology very early, and that is the advantage. Otherwise, They have invested so many years to develop a single vehicle, and then they come in the market and then they release the vehicle. That is very difficult things to happen. That's why these are all the advantages of AUTOSAR. That's why we are going to learn about this AUTOSAR going forward inside this particular course. That is it for today's lecture. Thank you. See you in the next lecture.